Okay, next is, okay, this is how to store. There is a exercise and example. This one we not yet touch for the equal sign. Okay, we only touch until real time, also not. Okay, we only touch until DUP last time. Duplicate operation. I teach you if you have the DUP, what you going to do? You're going to duplicate how many times? Okay, we done several example on DUP. Okay, now we're going to look into the next subtopic, which is defining words and as word. Kenapa dakwat saya tak keluar? Okay, we look into words than as word. Last time, okay, this one also we already look into. One of your friend asked how to define the sign, word, and etc. So the example here also we already look into how you're going to store. And I asked you last time, you can see one of your friend help me to convert this value, decimal value, to hexadecimal. So this also we already look into, okay? Okay, now about defining keyword, t-byte, and so on, real time. So this is new things for you. Although last time you look into the table, you already look into keywords, t-byte. So how many and how big the size? For keyword, it defined as quad word. Okay. Directive allocates storage for 64 bits or 8 bytes. So you know it's going to occupy at 8 box. If you have the stack, isn't it? So this is for byte, 1 byte. So if you have keyword, you're going to have all together 8 box or 8 bytes. For t-byte, directive to declare package in terms of BDC variables in the 10 byte package. So you're going to have 10 box like that. So this is in terms of size. So please make sure you remember the size. Now example were given here. For keyword first. This one, you know, it's going to occupy 8 box, isn't it? So it's give you hexadecimal already. No need for you to change. So this one, you're going to put into 1, 2, 3, 4, 5, 6, 7, 8. So let's see how it's going to be look like. If you're going to put into your stack 1, 2, 3, 4, 5, 6, 7. Okay. Let's say it starts at 7001. At this offset or address, first value, when you read this line, what you're going to do? Little Indian order, you're going to take from the back. Okay. If you have some comma, some number, ignore it first. This is the first thing that you need to look into. But start from the back. Not the back like this if you have another number. Okay. Now, okay, we're going to take the last 2 digits for hexadecimal value. Please make sure it is hexa, okay? If it is B, you need to convert to the hexadecimal. If it doesn't have any unit here, it is decimal. So you need to change to hexadecimal. So for this, it's going to tag like this. 7, 8, and then another one is 5, 6. Another one is 34. Another one is 1, 2. Then 7, 8, 5, 6, 3, 4, and lastly 1, 2. So all together 8 box, 8 byte. Okay. If let's say over here in front, there is no 1 here, what you're going to put here? You need to put 0. Please make sure, see that you're going to have 2 bits inside this. Okay, this is the things that you need to remember. 1 byte equal to 8 bits. So where is the 8 bit? Here will be 4 bits. Here will be 4 bits. 7, 8 hexadecimal. You change it to decimal, you change to binary, you're going to get okay, let's say 8 hexadecimal. 78 hexadecimal, what is in decimal?
$120.
120. So from here, convert to binary. But actually, this one you can direct convert to binary also, isn't it? If you still remember, there's a digital logic subject. Convert to binary.
It's 0, 3 ones.
0, 3 ones, yes.
Then 1, 3 zeros.
Yes. So this one direct from hexadecimal to binary also you already learned in your digital logic subject. So you will get 0, 1, 1, 1. This is 4 bit. You can see here. This is 4 bit. That's why you have 4 bit, 4 bit, 8 bits altogether, and 8 bit equal to 1 byte. Okay, that's why you need to have 2 inside. If you don't have 1 here, you need to put 0. What 0 will be looked into? Like 0, you're going to get 0, 0, 0 side here. That's why you need to write 0 if you don't have the value. You need to complete in one box two digit of number in hexadecimal. Okay, next you're going to have in vowels, integer val, I think. It's depend, you can name any name, isn't it? If you still remember. But this is the important on the size. How many size that you're going to have? T byte, you're going to have 10 bytes. What is the meaning by 10 byte? You're going to have 10 box. One, two, three, 4, 5, 6, 7, 8, 9. Okay. First of all, Little Indian order, you're going to look into all at the back. If you have comma, you're going to ignore first. Later on, you're going to continue, okay? So first, you're going to tag 3, 4. Because this is hexadecimal, no need for me to change anymore. So for this one, you need to also look into that it is it is valid for BDC code. If you still remember in your digital logic subject, okay, in BL subject, you look at the BDC, there is several numbers that invalid. Remember, right? So those invalid number, I think after 1000 and the rest, it is invalid number. So you're going to get invalid value. For this one, how to check that it is invalid or valid? So you need to look into like 4 here, what you will get. If 4, you're going to get 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0. 0, 1, 0, 0. And then for 3, you're going to get 0, 0, 1, 1. So this is still valid value, similar to others. Please make sure you check, then you know that it is valid, okay? That's why it's valid. Now, how you going to put 3, 4 here, and then 1, 2, then 0, 0. After that, another 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8, 0. I already have 9, isn't it? So all is already inside my package, inside my stack. 1, 2, 3, 4, 5, 6, 7, 8, 9. But I need to have 10 bytes. There is no value in front. So what I need to put? I need to put 0, 0. I need to complete the stack. If I didn't put 0, 0 here, after that, you're going to continue with another line. You're going to fill in, let's say, 3, 4 here. You're going to get wrong for the offset value. You're going to continue. The next is after this. Why it's important? Because later on there is also things that you're going to be asked, like integer var plus 1, integer var plus 2. This is related to your offset value, your address value. So if your point address is wrong value inside, so your answer also wrong, right? That's why you need to put 0, 0 to complete the size of the byte. So you need to check all the size first. Okay. Next, you have integer val t by 1, 2, 3, 4. This is in decimal. So you're going to see here, constant initializer must be in hexadecimal. So that's why it is invalid. But you can also try, if you have this value of decimal, can it be a hexadecimal value? Try to convert negative 1, 2, 3, 4. Did you get the answer or you get invalid value? Because this is BDC. Please check back. I don't want to repeat the digital logic subject. You have several invalid number. So invalid number that you cannot use for the BDC, because the BDC got invalid things. Okay, try to do this. If you have any question, you can contact me. Okay, now you have here in the defining real number data. So for real, define a 4 bytes single precision real variables. For real 8, It means that it is 8 byte. So you need to remember on real size. I think real not stated in your table. T byte only. So there is no real. So please make sure you add another one here in the table about the real size. Okay. T byte got here. So you know it is 10 bytes. But real is not stated here. So let's go back to the real. For real number, you can see the size of real. If it is a real 4, this means 4 byte. 4 byte is what? 4 box, isn't it? Going to have 4 box. For add reals, real adds, you're going to add bytes, double precision for real, and real 10 is going to be 10 bytes double extension precision. So if you still remember single precision, it is a 32 byte. Double precision 64 bits. Alhamdulillah. So this one is double extended precision. You're going to have this plus this. So you will get 100 bytes. So you need to remember all of this. Each require one or more real constant initializer. So the things is you're going to give in terms of constant initializer. This is constant initializer. Please make sure you still remember at this side. Constant. Where is it? For initializer, you're going to have a constant value also. Wait, okay. So this is a real number constant. How the format, how you're going to write. So this is going to be applied into your real 4, real 8, real 10. Okay. And tadi. Okay, so this one you're going to also change its later on to the hexadecimal value. This one, this and this is a similar format. Look back at the previous slide that I already shared to you. How it's basically for negative 260. What is this? And what is also the 20 DUP 0.0. So you're going to put into your stack. In terms the standard real number type, you're going to have 3, which is short real, long real, and extended precision real. So in terms of the significant digits, you're going to have for short 6, long 15, and extended precision real is going to be 19. So you have the range already. Normally, this type of question will be asked in your test on the multiple choice question, which is it just give you a question like this. Might be give you the value, so you need to know what data type is this. This is the approximate range, and what is the data type for this value. So you need to know, okay, this is a standard precision real. Next, you're going to see here in terms of example for add sub.asm. You're going to use this one from your previous topic, and then you're going to add data segment and also several double word variables. So let's take a look example here. Okay, this is dot data. The dot data, this one you're going to store first into your stack before you execute your dot code. Before you're going to execute dot code, you're going to store first the value of the data. Normally, as mentioned in the exam, it's going to be informed what address or what offset that we're going to start, because in your computer normally you have different value. If you just copy paste and then run, some start with the offset of like might be 4F30, some might be start with the different value for the offset. Now you're going to see here. Let's see what is happening. It is good here that it didn't give you any decimal or binary number, but please make sure you still remember on this. We learned in our previous topic, which is uninitiate byte. If it is word, uninitiate word, but you need to put in the stack in terms of the size. Okay. Okay, now we have let's say, okay, it's not give any adding or related to address, so just pick the value. Move EAX. This one is what? This is your destination. This is what? This is your source. Okay, please remember this. And the instruction given here is move. So you're going to move from source, and then you're going to put into the destination. This is your register, and please make sure you remember the size of your register here. It is 32 bits for EAX, isn't it? If it is AX, it's going to be 16 bit. Okay, now you have EAX. var1. Where is your var1? This is your var1. This is the word. And you're going to have this size. So you're going to store first here EAX equal to 10000H. If you go for your Visual Studio and you point it as a step by step, step over, once you already finish and you point at here, your pointer, you already execute and run this statement, your output for your register will be this one. Okay, so we go to the next. Second one, after you point up to the below line, you're going to have add, means you're going to addition process. You have the VAL2. Where is your VAL2? This one. So you're going to add this with your EAX into your EAX. You're going to add this into your EAX. So you're going to add another value. Let's say you have 10K. RM10K, and then you're going to add 40K into your account, into your EAX account, CIMB or Maybank account. So how many you have now? You have 50 hexadecimal. Okay, 50K hexadecimal. Next, you're going to go to the move. Now here, now you're going to point here and you need to execute this line. You're going to sub. Now you're going to deduct your account. with the value of VAL. From here, you're going to deduct the total value of 20k hexadecimal. So you deduct, you will get the 30k hexadecimal for your EAX now. So you can also copy and try to execute step over in your Visual Studio. Another one is move final val EAX. Before that, one of your friends still having a problem. It pop up the error of virus. Most of us last time already solved this problem. Might be after finish this class, you can stay and ask for those who help to remove the error, because last time it's just an error. It's not that it's not exactly Trojan in your file. Okay. Here you can see you're going to do a from source to destination. This value you're going to store into your final val. So now we have this. So our final val now will be 3000 hexadecimal. And if you call the dump register, last time in last class also I already asked you, check this. If you write this one in your coding, and what is happened if you didn't write this dump register? The function is what? To display the register value. Okay, to display the register. If you did not call dump register, you're not going to display the register. So last time I asked you to try to delete this line and to try to have this line. You need to see the difference. This one is write the following program in the. Okay, this is also quite similar, but for this one it's directly give you the value. You can see it's basically similar to here, but at now you already put the data segment. But in this one, you didn't put any data segment. Instead, you're going to give direct value. Okay? Direct value to your coding. So let's we move to the symbolic constant. We have only small part in terms of this subtopic, equal sign and also equal directive. So a symbolic constant or symbol definition is created by associating an identifier. Please make sure you remember back with a integer expression or some text. So you can have a integer, you can also have a character. Symbol do not reserve storage. So it's not going to reserve any storage in your stack. Okay, use storage, symbol no. If you are having a variable, then it yes. Value change at runtime, no for symbol, and variable we're going to change. So let's say here, this is about the equal sign directive. So use the equal sign directive to create a symbol representation, integer expression. In terms of write out, you're going to put any name. So here might be you need to have yellow, blue, or whatever name here, and then it's going to be equal. This is the symbol sign. And in terms of expression, you can do any expression here, but in terms of integer, this is the example. Expression is 32-bit integer. You're going to express expression or a constant. So maybe it's redefined. A name is call as a symbol constant. So example, you're going to have count here, and you're going to use the equal sign directive equal to this one is direct value. So you know for count you have this value. You can also put in the dot data. In dot data you can have like count and then byte, and you have 5 hexadecimal. But in terms of if you want to use this type of things, you can have the equal directive. You can also have like move AL 5 hexadecimal directly like this one sentences, it already similar to this. Move AL 5 hexadecimal, you move to here, isn't it? But in these sentences, you want to use the equivalent, equal sign. So you have 2 lines here. And count, you know that this is your source. What is your source value? It is 5. So you're going to put AL equal to 5. All of this is just for you to know that there is a several way for you to write a program. Last time you have like dot data. In terms of data segment, you can have count by 5 hexadecimal, let's say. So you have 0.5. This one is also 0.5, but we know that it is a value of 5 hexadecimal. Okay. Then you have code. You just call it as count. Okay. You can have MOV AL COUNT. So you call this one, you put in your AL. So you get similar output. You can also ignore this one. You did not use the data segment. Instead, for your code, you can just directly put like 5 hexadecimal. So this one, just one single line here, you get the similar output. And you have another one. You use the count, you have use the equal sign, you can get a similar output. So there is several ways. So let's say in terms of write up programming, maybe you say, why are you are using like this? I put the dot data and so on. I think this is the correct program. Compared to your one is not a correct program. There is no just a scheme. In the programming, there is no like one fixed program. You can have a variety way for you to get a similar output. Okay, so that's why you learn several way to do the program. And here in terms of equal, EQU directive. So the EQU directive associates a symbol name with the integer expression or some arbitrary text. Arbitrary text, you still remember, it's also quite similar to your character. What else in your character? So here, example, going to see, you have pi EQU equal to this value. Okay, in terms of you want to use the equal sign, you can also have pi equal to 3.1416. Let's say you put hexadecimal. So it is a variety way for you to write. And then press key EQU. Press any key to continue. This is the things that you're going to pop up, like if you learn on C programming, print screen. Okay, press any key and then continue. You have ... here, and then you have the value of 0. So this is in terms of the text expression. So you have the dot data prompt but press key. So this is press key. What is inside of the value? It is continue here. You can see example. If you have my name, EQU, right, blah, 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 blah. Okay, this one, it will print out whatever you are putting here, but the value that will be changed is on your defining here for adding the new line for the value. Okay, so this one, you're going to look into the value if basically you call the data on top. If you have the value, it will be putting here. Okay, so now you can see you have the message dot data my message by my name. So the size of your my name here is byte. Okay, so your size of your my name is a byte, and you can have your dot code call CLR screen. So this one is for you to clear your screen, just to clear your screen. After that, you have the normal coding command instruction that you always use is a move. You have the value of offset my message. Start with the address of your offset. You're going to have your my address here. And this is offset start might be in your offset's going to start at 000. And you're going to put it in the EDX register. So your EDX register will have the offset value of your my message EDX. After that, what will happen? You're going to call write string. So write string, you're going to display your message. What is your message? Is my name. Where is it? This is the things of your message. And last time you already looked into what will be having. You need to have a double or might be a single, isn't it? So both of it you can also use for the string. If you still remember, last time we already learned on this. Where is it? String. Okay. You need to have a single character enclosed or a double. This is a string constant. You can have any type of embedded code that you want to print out. That's why you need to learn the theory first before you can apply in your program. Okay, we continue again. Where is it? Okay, here. So what you're going to see in terms of your output after you call the write string, you're going to display your answer. So write any name here. This one is not your output. Okay, this one is like instruction for you to press any key after you already have this output. This is the one, the outputs that you're going to get for your instruction. This one is just a display on your output. So please try to copy paste this one in your Visual Studio and see. Play around with this value. Might be you can also play around with the value here. Is it affect your message or not? Okay, I think it's not because this one is just a size for you to call the message. Okay, So that is only things for your module 3. Module 3 will be not covered in your test 1, but this is the basic things before you can move to your module 4. So in your module 4, later on, you're going to see it's much more advanced. But before you're going to go directly, you can see, okay, see you're going to play around with more advanced. In terms of the offset here, you need to know in terms of addresses. And where is the stack? Okay, you can see here. After this, you're going to learn how you're going to put into your stack. Okay, you can see. But this is in terms of RPN. You have another one is postfix or infix. Postfix or infix. But this is how you're going to store in your stack. The way how you're going to store also is important. It is from your module 3. What else? This one in terms of your addresses. Okay. This is in terms of your addresses. You can see here, you have 1011. This is the address. That's why it's important for you to know at this box what address. This box is what address and etc. If you put inside a wrong value, then you going to get wrong. Later on also you're going to learn. You can see it's quite similar to your module 3. You were given with the code and you need to know what is the value for like EX, what is the value for your BX. CX is not here. I think okay, CX is there. So all of this occupy you the information and knowledge for module 3. That's why module 3 is very important in the whole COA subject. If you did not understand module 3, you cannot move on to next topic. Okay, let's take a break 5 minutes. After that, we continue with module 4. If you have any question, you can also ask me after this, okay? So let's take a break first. Did I share the module 4 already in the e-learning? Not yet.
Not yet, Doctor.
Okay, I share now. So you can directly take out your module 4 to continue. Wait, I share in the e-learning. Bercakap ke apa? I confused. Okay, I already upload the module for your e-learning. You can have a look now. Okay, class, let we continue with our module 4. Are you here? Okay, please enable your webcam. We're going to continue. Okay, please remind me also, yes, tomorrow we're going to discuss, okay? We look into one by one for the subtopic, each subtopic for your test 1. And one of your friend, that one is OS subject. Okay, all of you need to take the test at 23. Forgot already what is the time and duration, but I hope that you already ready for the test 1, because tomorrow we're going to discuss together. But in terms of question answer, I will also ask you directly. I hope that you can answer. Okay. I'm going to share my screen now. Okay, this is our module 4. And for module 4, we're going to look into machine infrastructure characteristic, type of operand. Okay, last time you learned in your module 3, that's why I mentioned it is continuous from your module 3. You learn operand, you can have the minimum. Dari tadi ya, sejam lebih dah. I already more than 1 hour, I didn't call anyone. Okay. Amira Azkia. Amira? Amira Azkia? Amira? Amira Azkia, are you here? Amira Azkia? Okay, you did not respond. I'm going to kick you from this webback. Eng Kai Zian.
Yes.
Why you did not enable your webcam?
I forgot to open it.
Okay, what is the minimum operand that you can use? This a minimum operand. What is the minimum and maximum operand that you can use in one single instruction?
Alright.
Yeah.
Is that size of the?
Not the size. How many operand that you can have in one single instruction? For the minimum and the maximum.
0 to 3.
Okay, so the minimum is 0 operand. The maximum is 3. Thank you. So this one also you already learned in your module 3. And here in your module 4, you're going to continue the thing, but in terms of how you apply from module 3, how you apply your knowledge, how many operand that you can write, 0, 1, 2, or 3 in one single instruction, isn't it? So you can see the difference. If you have 0 in your one instruction, 0 operand, how long your program will be taken? If you are using 1 operand, how long? Although you want to have, like, let's say 3 times 2 equal to 20. So this is the program that you want. You're going to have example if you using 1 operand for instruction, you're going to have longer program. If you put 3 operand in one instruction, you're going to have shorter program, but your output is similar. So that is will be having in terms of the difference when you are looking at the type of operand and how you're going to apply also. In terms of addressing mode, this is the one that I mentioned about offset. Okay, offset, about your address. Macam mana kawan you nak masuk ni? Okay, that is about addressing. Okay, we already look into our module 3. And instruction format. How are you going to look into the instruction format? This one also from your module 3. Let's take a look one by one. This is the overview. You can read it by yourself in terms of the ALU, arithmetic logic unit. This one is not a new term. You already look in your module 1. And why? This is the important question throughout your module 4. Why assembly language? Why learn assembly language? This is also similar question from your module time last time. Okay. Wait. Okay, sorry, I got a message from my senior again. Actually, we discussed a few things related to our project, so it's quite important. Okay, sorry. So here is the hierarchy of our computer language, especially for us to differentiate in terms of machine language and also assembly language. Machine language is not assembly language. So where is machine language? Where is assembly language? Okay, here is our assembly language. Last time, I already informed assembly language is a basic language if you compare with your C programming, Java, Python, C++, all the high level language is not assembly language, which is much higher. So this is C, C++, Java, Python. So all of this is the high level language. And it is a machine independent. Okay, it is machine independent. But your assembly language, it is a machine as a specific, but it is not machine language. For you, for your computer, when you are having an assembly language, or it called as low level language, for your computer to understand, you still need to convert your assembly language to your machine language for your computer understanding. This one is for programmer understand. But this one is for your computer or your machines understand. Okay, this is the hierarchy, how it's going to be connected. Later on, you're going to see also there is another diagram for you to connect from high level language to assembly language, from assembly language to machine language. What you need to have? You need to have assembler to convert your assembly to machine language. So from high level language, can you directly go to machine language? And what you need for you to convert ataupun is in vice versa is a converter, or for you to change the program for your computer understanding. So assembly language is need a assembler. Okay, but this one we're going to look later on. Okay. So in terms of differentiation, machine language, alhamdulillah, native to a processor is going to execute directly by your hardware. And how your machine language look like? Last time I already informed you. Your computer only understand 1010101010. So the instruction consists of binary code only, 0 and 1. That's why you cannot understand. The one that understand machine language only your computer. And in terms of assembly language, is a programming language that you understand. And normally we use a symbolic name like move, add, and etc. So it is symbolic for us, just for us to understand, to get later on to convert to the machine language. To represent our operation, register, memory location. It is slightly higher level language from machine language, but it is not higher level language, okay? Slightly only just higher from machine language, but it is still a low level language. Don't confuse with this explanation. It is not high level language, but it's slightly higher than machine language. And it is a readability of instruction because we can read, we can understand as a programmer, which is better than machine language, which is you don't understand in terms of 1010. One-to-one correspondent with machine language instruction. So means, let's say you have MOV EAX 101 hexadecimal. This one is one-to-one converter. So it is direct. Here is the diagram. If you can see a comparison. Okay, in terms of the comparison here, assembler, assembly, and also your assembler. You can see assembly language, you're going to need your assembler to convert your assembly language to machine language. That's why just now I mentioned to you, you need to have something for you to convert from assembly language to machine language. What is the things that you need? You need to have the assembler. If you want to convert directly from your high-level language to your machine language, what you need? You need a compiler. But compiler also, you can convert C++ to directly machine language, and this one also can convert to your assembly language, which is similar. Compiler. Okay, again, compiler can convert your high-level language to assembly language, and it also can convert directly to your machine language. So you need to know compiler translate high-level language to machine code, and either directly or indirectly via your assembler, like this. After that is using the assembler. And for assembler, it's going to convert from your assembly to your machine language. So you need to understand, because normally we will ask in your MCQ question, which is our MCQ question is going to have a multiple choice question, right? So multiple choice question, you're going to have, let's say, what is the converter that you need for you to convert assembly to machine language. So that is kind of question can be asked. Okay. High level language. So the advantage. Okay, why you need to have C programming, C programming, Java. Why you need that? Because you already learn assembly language. Why you need a lot of others language to be used? So here, high level language is faster. Why it faster? There is a reason why it's faster, because it is a fewer instruction. Okay, I give you example. Jauh sangat. Okay, let me give you example. Let's say for C programming or C++, you only have like apa ya? Okay, let's say you want to have A plus B. Okay, instruction A plus B. Using C++, you only occupy, let's say, one line. One line for the instruction to have A plus B. But for your assembly, you need to have maybe A plus B. Okay, maybe you need to have two lines like EAX, A. You need to have A first inside, isn't it? And then after that, you're going to have add B. And then you're going to call dump register. So you're going to have EAX equal to A plus B, isn't it? So you have several lines. So you have many lines compared to if you are using C++ or Java. To get this instruction, you just using one single line. That's why it is a fewer instruction code for this statement. That's why it's much more faster. And then program is easier to maintain. Similar also as a reason as above, if you have like only one line to have A plus B, you can only modify this line. But if you have like 3 lines just now, of course you need to modify this line, this line, this line, isn't it? So that's why you have quite hard for you to maintain. Or maybe you want to modify. However, assembly language is not portable. Okay, this program for high level language is portable. You easily for you you can use with a little or no modification and to directly go to the machine dependence. And compiler translate target to your machine language. So now let's take a look, because this one is assembly language is not portable, means that it is not a machine dependence. You can see at here. Machine specific, and this is a machine dependence. Similar also in this statement. Okay. Now, why? Because just now, okay, my lecturer said that C programming, higher level language got a lot of advantage. What and why now we are learning on assembly language? Why don't we just directly learn high level language? Still, okay? Okay, still you can see in terms of several advantages. Several advantages. First is accessibility to system hardware, which is it is useful for implementing on the system software, and it can also easier to be accessible. And it's also useful for you if you have a only like small program for the small applications that you want to develop. and it is space and time efficiency because we can understand the source of program easily, and tuning a program performance and writing compact code. So this is some advantages. Sometimes you can see like it's better for me to direct go to the C programming, but if you didn't have the basic from assembly language, it's hard for you to direct learn the high level language. Here is another advantage, which is computer designer need to deep understand on the instruction how to use. So that's why writing assembly program is much more easy if you compare to C or Java. To able to write compiler for high level language, you need to be expert with the machine language. So that's why just now I mentioned, right, that's why you need to have the experience to do the assembly language first before you can go to higher. Okay, this one in terms of our processor, this one is not, I think not important, but it can be also asked in your multiple choice question. You can try to read it in terms of your x86 64-bit system normally. Okay, this is your basic microcomputer design. We're going to look deeper in your module 5 later on in your section 5.2. But this is just for you to get introduction first. Okay, what is the block diagram of microprocessor look like? Later on, you're going to learn on theory again, okay? So it's quite boring. I don't like theory. Okay, in terms of table, when you have the table, please make sure you remember all the table because we can easily ask you a question. What is the correct definition or description for a clock? What is control unit description? What is ALU description? We just like might be give you the drop down for you to pick the correct answer. In your COA, there is no drop down for part B for test 1. Multiply and division got. Okay. For clock, this one you learn already in digital logic subject. You can try to read this. This one is normal information about a clock. You also have like one cycle where it's going to start and why clock is needed. This one trigger event. This is all you already learned in your digital logic subject. Okay, instruction execution cycle. This is a CPU block diagram. You have fetch, decode, fetch operand where you're going to apply here in the next example. So where you're going to apply fetch, decode, fetch operand, execute, store, output. Let's say you have here in terms of your memory. In your memory, you write the code. Of course, you're going to have the data. And if you still remember, you're going to have a system bus. Whether it is in terms of data, this data. In terms of your address buses, address, if you have address in your memory, of course, you're going to have address, right? So it's going to connect to your address bus. In terms your code, also, you can connect to your bus system. And all of this will be connected. You're going to see, you're going to start with the code cache. After you have the code cache, it's going to be look into your code. You're going to have the instruction decoder. This decoder, you're going to, this one is decode your instruction for you to be a machine language. It's going to pass to your control unit. Then your control unit will pass around to your, inside your, this one is your CPU, right? You're going to have CU, you're going to have a register, you're going to have ALU. And sometimes if you still did not finish and you cannot pass to your control unit, you still need to have the instruction pointer, which is, if you have the code like this, point 1, line 7, after that line 8, after that line 9, it is the instruction pointer. So if you still did not finish, you at the line 8, so you're going to loop around back to read another code statement for line 9. But it's going to pass one by one. And in terms reading from memory, how it's going to be look like. So you have several cycle in your clock. You can also having like this. There is several way for you to have the clock design. The waveform it can be rectangle, it can be also in terms of sinusoidals of your waveform. And you have the addresses, how it's going to be start. When you start, where you going to do first. Later on, there is instruction, okay? Cycle 1, what is happen, cycle 2. But it is depend on this structure. Let's see the flow. First of all, step by step. When you have multiple machine cycle, require when reading from memory. Just now you have a memory here. When reading from your memory, what will happen? Much slower than CPU. Okay, when you try to execute. Step by step. First, you're going to have your cycle 1. For your cycle 1, you're going to have address placed on your bus, which is we call as ADDR. You have your code here. First of all, what you're going to have, you're going to have the address first. Then you can have the value inside. So you need to have the address. That's why address is important. As mentioned in your question, it will directly give you the address first, the address value. So you can see in terms of the address, it will be start first. Second one, that is the things that happen in your cycle 1. You can see in your cycle 1 only trigger your address to look into what is the address value. After that, you're going to have the read line, or we call as RD only. You need to set it as a low value first. So to enable, you're going to set it to low for the RD. And for the third cycle, you're going to wait. So for this one, it's going to go for a control unit later on. So now on the cycle 3, you're going to have the data. For the CPU, CPU wait for one cycle for memory to respond, and then you're going to have the read line goes up back, and it's going to indicate your data. So from here, it's going to go up first, and you're going to have the data value. This one just wait. CPU just wait for the cycle 3. And cycle 4 is going to be having the RD equal to 1 back. and you have the value. This one is just example on the reading from memory. It's not going to be fixed. But in the example of this reading cycle, this is the flow. How to run the program? What is basically happen when you have the source file, the program that you write, .code, .data, all of this is our source file. And this one is assembly language. Before you can give to your machine language, of course you need what? You need to have the assembler. So for step 1, you have this one, text editor of your source file. And then you need to have assembler to assemble your code in the program that you written, and you're going to divide it into two. First is the object file, second is the listing file. After you have the assembly language, after you're going to have the assembly language, you can have the assembler to convert to two, object file and listing file. And then you're going to have, after you have the object file, okay, after you have the object file, this object file will be execute. Okay, before that, before you can execute your program, of course you have the library on top. That's why you need to have the linker in your program. If you don't have a library, your library you are using the Irvin, right? You don't have the library, which is link library, you cannot execute the file. Normally it's going to get error. Maybe you can remove your Irvin, or maybe you have several library on top. You remove the library first. Then you try to run your code. Can or not? Of course not, because you need to have the library. And how the library going to be in? You can see it's not in the source file. This is your program, right? You can see library separate from it. You're going to save it in like different folder, but it's going to link to each other using a linker. After you execute, this linker will execute, and it also will come out with the map file. This one you cannot see on the background. After you execute, of course, you're going to get your output. After your OS loaded, that's why you can see AX is what, EBX is what on your output. This is what is basically happen in your program when you execute your assembly language. Okay, what content in the listing file, what you going to have in the object file, map file, and etc. So let's see first in your listing file. So it used to see you how program is compiled. You just compile using your assembler. Compile, not yet execute, okay? You just compile, and the source is content of source code, addresses, object code, which is your machine language, segment name, and symbol. This one is very important. This one is very important for you to remember, because some of the question can be just directly asked, okay, what is content in the listing file? Which one is correct? So we will give you a several, and you need to pick which one is the correct one. Okay, example here. This is the program. Where is what is all of this? Because you did not see this one. isn't it? You just see .code, blah, 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 blah. But actually, there is addresses and etc. in your program when you execute. Okay, this one is 32-bit addresses indicate the relative byte distance and statement beginning code area. So normally it's going to start with 0, 0, 0 address. 0, 0, 0, 0, 0, 0 until you have the first instruction. Okay, until you have the first instruction, your address will be start at 0, 0, 0. That's why your stack normally will start at 0, 0. But sometime in our computer, even in the question, normally we did not give you directly the address start from 0, 0, 0. Okay. So what else? Over here, it's content no executable instruction, which is you're not going to execute this one. It is just a directive. Here is the assembly language instruction. Each of these are contents of 5 bytes long, and this one is hexadecimal value. Example here is 10 kilohexa. We have 40 kilohexa, and this is the addresses. Okay, normally you're not going to see this in your program. So this is in term of your listing file, and this is map file. What is map file? So you have map file of informations about each program segment. You have the starting address, ending address, size, and segment type. So starting address, as mentioned sometime, no, you can see here it start on 0, 0, 0. But here you can see, oh, okay, similar also, start at 0, 0, 0. And ending also will be given. So what is the end of the addressing? And the length, which is the size. And segment type. What is the segment type? Whether it is text, whether it is digit. So it is given there. Design decision for instruction set. So from here, when a computer architecture is designed first, the instruction set format must determine first before you can make any decision. So before that, you need to know in terms of the architecture of the design first. You need to design what program that you want to write. Selecting format is often quite difficult because instruction must mesh with your architecture. So if the architecture is well designed, you can see you can have similar on our computer architecture nowadays. We use it, I think already like decades. Okay, now ISL level define the integer between compiler, which is high level language, compiler, right? And also hardware. It is a language that both them understand. So example here, you have C program, you have 490 program, and then you have the compiler. ISA is between of it. Okay, you're going to have program compiled to the ISA program first. And then your ISA program will be executed to change it for you to use in your hardware or your computer. ISA are measured by several different factors, so including the amount of space, the complexity, length, and total number instruction. So this is about ISA. Normally, all of this will be asked in your MCQ only. So you need to remember the theory. So forget about all the theory. I hope that you can try to read it back, all the theory, because mostly it's going to ask in your MCQ. Let's move the things in terms of coding or programming. So this is elements of machine's instruction. Okay, machine instruction in terms of elements of machines instruction representation. How we're going to represent it, type of instruction, number addresses, and instruction set design, which will be related to your module 3. So you can try to read these elements of machine instruction. Okay, now you have what elements? Normally we call opcode as your operation code. This one you learn already in your module 3. We learn on move, add, sub. This all is instruction and we call it as a opcode. And then we have the source operand. Source operand is operand that are input of the operation. Might be it can be in digit like okay, M or V, E A X, 5 hexadecimal. So this is your opcode. This is your source operand. And result operand reference. So this is your result operand reference, which is your destination. The operation may produce a result. Next instruction reference is tell the processor way to fetch the next instruction. So the things that like loop or might be called sire. So you have something that you already have sire, then it will call that, which is next instruction reference. So let's say this is example for your program, some portions of your assembly language. So this is the part of your opcode. You can see here, this is opcode. And this is your source. I already mentioned to you, at the right side is going to be to destination from source. Move to destination from source. That's why this one is your source operand. And this is your destination operand. And source operand with immediate value. Just now I give you, this is similar operand but it immediate value. It directly give you the value. Instead of total, you need to find out where is the source, isn't it? And in terms of source and result operand, which is destination, it can be in 4 areas, which is main virtual memory, or might be CPU register. This one EAX, DBX. Wait, I got call. Sorry. Okay, sorry. Let's continue. We have here in terms of the source and result for the operand. You can see main or virtual memory. Mana saya perlu? Okay. Processor, CPU, register. Later on you will see in terms of the example. Okay. This is the type that you can write. For you to write for the source and destination. Let's say you have add something. This is your destination. This is your source. So what type or what things that you can write inside? So first is main memory or virtual memory. And then you have a CPU. You have also immediate value. And you can also have the input-output device. Let's see the example where what is the main memory, what is a CPU or register, immediate and input-output. So let's say here you have move AX total. Okay, this is your destination. This is what? Register. So you can see here source and also destination. Your source here is memory. Why it's memory? Because you already put in on top data total byte 1010 byte binary. Let's say example, okay, in your program, supposedly you're going to have on top, right? And I asked you last time, I already informed, if you have this data first, you're going to store where? In your stack. Stack is your memory. Okay? That's why you can have memory as your source or destination. You can have both. Okay? And this type of, this one is your memory. You already look into how it's going to be look like. Now you look into the CPU register. This is your CPU register. This is your CPU register. Okay. Register. So you can have both register for destination and also source. You can write in your source and destination. Register memory. The third one is immediate value. You can have the immediate value like this. You can have immediate value 10 binary, 10 hexadecimal. So all of this is immediate value, which is from here value you just directly go and send it to the destination. Direct. No need for you to look into like this, right? This one the register, right? You need to look into the register value inside. What is the value inside the register? Similar also like this total for the memory. You need to go back to check in the memory what is the value. But this one is direct. From this value, you just grab it and put it into your destination. And one more thing is your input-output design. So for input-output design, it is from input-output, it is like this. Read integer. Read integer, this one, from your keyboard. Call read integer. So means that you need to key in something, or might be this one you already declare on top. Last time you look into at the last chapter for your module 3, read for the call function. So read integer, let's say you press in your keyboard 7. So this is the value, let's say. Or might be you already directly put here read integer. So what is the value? So it is a from input output. And it can be also a display. So you're going to display for your output display the value on the read integer. So next instruction. You can see also in terms of next instruction, where is it? I give you example just now. In terms of like might be you going to loop it, loop, might be you can also jump, might be you can also have a call, but you're going to go to the next. Jump to the target. So where is target? You go back to D003 offset. Then you continue, jump again. Loop this instruction. In terms of instruction representation, this is the one that in terms of size, first in terms of size, and then you're going to see also in terms of operand inside. Let's say you are having 16-bit. So you're going to separate it into 4-bit for opcode, 6-bit for your operand, whether it is source and destination. Okay, example here. You have the opcode of add for address, sub for subtraction, mul, divide. So all of these already also look into the module 3. But last time you learned it on as a instruction. And you learn on your module 4, it's called as opcode. And you can also call it as a mnemonic. Okay, mnemonic. That indicate the operations. So you can see example of your single line. You have instruction type, which is the type.
Doctor,
Yes?
it's already 10:05 right now.
Huh?
And some of us has next class,
Oh, okay.
another class to attend.
Wait, okay, let's see. We're going to continue back in our next class, instruction representation. But tomorrow I'm going to focus on your revision only, okay? Later on next week we're going to continue in instruction representation. If we have much time tomorrow, we're going to continue with instruction representation. Okay, sorry, I didn't realize it's already 10 a.m. Thank you all. For the rest, still did scan your QR code. Please stay first. And those who already scanned, you can leave. Thank you and meet you again tomorrow.